Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so the trick to doing this is we're going to compare this series with n3 2. The trick to doing this is to realize that that there exists a point where e will always be bigger than e to the power of 1 over n, because e to the power of 1 over n looks something like this. E is a constant. It looks like this. There exists a capital N where beyond capital N, this e here will always be bigger than this 1 over this e to the power of 1 over n. So there exists a point where this e here will always be bigger than this. So the trick to doing this is to realize that this e here will be bigger than this thing. But the question is, how do you go about realizing that this e here is bigger than e to the power of 1 over n? What does e to the power of 1 over n even mean? So for example, it's like, well, first, look at this bit here. This bit here, the highest value that this could be is 1. And then it gets smaller and smaller because n is increasing. N is moving from 1 to infinity. So just this 1 over n, it will just get smaller and smaller. So realize the highest that this thing here could be, this bubble here could be, is 1. And then it gets smaller and smaller. So what does e to the power of 1 over n even mean? So it's just like me giving you this. What is e and then less than 1? So let's say 0.97, and then the next one, e to the power 0.82. For example, let's say e to the power of 0.57. Well, what does it even mean to have this? So to try and understand what's going on, let's just imagine e to the power of. Remember, this is getting smaller and smaller. Let's just try and understand this. Let's just say a half. Well, e to the power of a half means you're searching for a number. When you times by itself, it gives you e. Now, what does it mean to have a power of a third? Don't forget, our number here is getting smaller and smaller. Our number here. So we are just trying to understand what it means to have e to the power of 1 over n. So to the power of a third means you're searching for a number. When you times by itself 3 times, it gives you e. So you can see that this thing here, this number here should be smaller than e. This number here, just this one number here, should be smaller than e, because, well, what does it mean to have e to the power of, let's say, a quarter? Well, e to the power of a quarter is you searching for a number. When you times by that same number 4 times, it gives you e. So the answer here must be smaller than the number e itself. So hang on, if you have let's say this is 1 here, and let's say this is e here. If this number gets smaller and smaller, then it gets smaller and smaller each time. If you look at a half, this thing here, it will be smaller than e. E to the power of a half. So you're searching for a number when it times by itself, it gives you e. But then this thing here, e to the power of half, you're just looking at one block. You're just looking at this block here. Well, this block here will be smaller than e. Now, e to the power of a third. So you've got 3 blocks here. Well, e to the power of the cube root of e, which is this one block here, will be smaller than e. So you can see that e is here, 1 is probably around here. So each time you can see that it's getting smaller and smaller. It has to be smaller and smaller, because let's look at e to the power of a 7th. It means that you're looking for a number. When you times by itself 7 times, it gives you e. So this one block here will be smaller than the e. So it gets smaller and smaller each time. Now let's try and understand what happens when it's less than 1. So let's say a number that's smaller than 1. Let's say 2, let's say 3, and then to the power of a half. So you're looking for a number. When you times by itself, it gives you 0.3. Now let's try and understand what it means to have this to the power of a third. It means you're searching for a number. When you times by itself, it gives you a third. So let's look at the diagram. 0 is here. Let's say 1 is here. E is all the way up there. You see, when it's bigger than 1, it gets smaller and smaller and smaller and smaller. But let's say if you start at 0.3, the square root of 0.3 you're searching for a number. When you times by itself, it gives you 0.3. Well, the square root of 0.3 will be higher than 0.3 itself. It will be higher than 0.3 itself. For example, if you look at this, what's the now let's say a quarter, and then you square root a quarter. It means you're searching for a number. When you times by itself, it gives you a quarter. Well, that would be a half. A half times a half gives you a quarter. You can see that a half here is bigger than a quarter itself. So when a number is smaller than 1, if you square root it, it gets bigger. If you cube root it, it gets bigger and bigger. So here it's heading. It should be getting bigger and bigger when it's less than 1. When it's bigger than 1, like in the case of e, it gets smaller and smaller and smaller. It is actually heading towards the limit of 1. So let's go back to try and understand what's going on here. So let's just try and understand this bit here. Let's just try and understand. Hang on. Let's just try and understand this bit here. What it means to have a. Well, let's just try and understand this bit here. Sorry. Limit of e to the power of 1 over n. Let's just say the limit is y. So we are trying to investigate this bit here. We are just trying to understand this thing here. So limit of this thing, natural log equally to both sides. That will then give you this. The natural log equally to both sides. That will then give you this. And then the limit of this, as n heads towards infinity, would be 0. So natural log of y equals 0. Exponentiate both sides. So that will then give you this. Tidy this up. So the limit is actually 1. The limit of this thing here. The limit of this thing here is 1. So the limit of this, as n tends to infinity, is 1. So what that means is it's going downhill. The limit is 1. But let's just try and understand what's going on here. Hang on. Let's just imagine even if we don't have, so 1 is here, e is somewhere. Hang on, not to scale. So 1 is here. E is somewhere here. E is somewhere here. We know that it will head towards 1. The limit will be 1. Even if you have a 7, let's say a 7 here, the limit will still be 1. Because, well, work this out. Let's say we are trying to find out the limit of this. Natural log equally to both sides. This will then come down. Natural log of this. That will then give you this. This here is a constant. Natural log of 7 is just a number. It's a constant. So you can take it out here. Well, the limit of this block here is 0. So 0 times this constant here, it will be 0. So the point I'm trying to make is that even if you have 7 to the power of 1 over n, it will still head towards 1. The limit will be 1. Now let's look at what happens when it's less than 1. So let's look at what happens when it's 0.3 to the power of this. Natural log equally to both sides. That will then give you this. Blah blah. The limit will still be 1. So the point here is that, hang on, bear with me, where am I? So the point here is that e, this thing here is going to get smaller and smaller. The limit will be 1. So what you should do is to compare this with the number e itself. So what you should do is compare this with the number e itself, because beyond a certain n, e, the number e, the constant e will always be bigger than this thing here. The constant e will always be bigger than this thing here. Will always be bigger than this thing here. Well, e is a constant. You can take it out. So that will then give you this. So now we know that this thing here will converge. You should, because this p here is bigger than 1. So it will converge. Well, you should recognize that this thing here will converge. Well, if the whole thing here converge, well, this whole thing here is bigger or equal to this thing, so this will have no choice but also to converge. So therefore, our series will converge. Okay.